Welcome back, everyone. Today we will study how to implement polynomial regression. First, let's review what lasso regression is. Lasso stands for least absolute shrinkage and selection operator. But don't let the name intimidate you. The core idea is actually very intuitive and even beautiful. Imagine you're building a predictive model. Maybe you're trying to estimate a person's risk of developing diabetes, or predict housing prices based on many features. You have a data set with dozens or maybe hundreds of variables. But here's the challenge. Not all variables are useful, and using too many can lead to overfitting, poor generalization, and complexity that we don't need. This is where lasso comes in. Lasso is a kind of linear regression, but with a twist. It doesn't just fit a line to minimize prediction error. It also applies a constraint that shrinks the coefficients of the less important variables, sometimes even down to zero. Why is this useful? Because it does two things at once. First, it simplifies the model by removing irrelevant or weak predictors. That's feature selection. Second, it prevents overfitting by shrinking the model's reliance on variables that add little value. You can think of lasso as a gentle disciplinarian. It says, you can use these predictors, but only if they truly help. If not, they get pushed aside. Mathematically, lasso modifies the loss function of linear regression by adding a penalty, the sum of the absolute values of the coefficients. The more complex the model, the larger the penalty. The result is a sparse, interpretable model. Later in this class, we'll explore how to fit lasso models using Python, how to tune the penalty parameter, and how to interpret the results. You'll also see how lasso compares with other regularization methods like ridge regression. But for today, I want you to focus on the philosophy behind it. Lasso is about balance, finding a model that fits the data well while also staying lean, simple, and robust. So let's get started.